Welcome back. We're walking through examples from Chapter 1. So let's go through examples 1.9 through 1.11. Right now we're going to give you an example about linear demand. And if you remember algebra, linear demand is nothing more than a straight line, or your function has exponentials, basically no exponentials, or exponentials of 1. So we're going to use here an example of economics because a demand curve is often used, and all a demand curve is it says the quantity demanded, or the amount people will buy or purchase, is a function, therefore it's related to price. So typically, as prices go down, as we have a sale, the quantity demanded would go up. As prices go up, the quantity demanded tends to go down. So that's why in our functional equation, notice we have a negative sign in front of our, essentially what our slope is, times our price. As price goes up, quantity demanded goes down. It's called an inverse relationship if you remember math. We've got a very simple equation here. Again, a linear equation. A, which is a constant, minus B, which is the slope, times the price. So if you remember back, this is very similar to your algebra days if you remember the equation y equals mx plus b, where m was the slope and b was a constant. So to lay this out in Excel, again, I put some assumptions here, some different price starting points and different increments. And of course, that's related down to this cell here. I've locked it there. And then this is just this cell with these added so that I can change, and I give some flexibility to my model, because again, this is all about how do we do some of the modeling of these functions within Excel. I can model this linear function. In this example, they told us the constant was 20,000, so I input that, and they told us the slope was 10. And over here, we just do the equation, which again, I didn't lock these because I want them to change as different at different price levels. Notice it's simply taking this equation, my constant minus the price times the slope. And notice, as a quick check, we have as the price increases, my quantity demanded is decreasing. And you've got a handy little chart here that you can do in Excel, which automatically makes it. Let me show you how to do that once again, just as a reminder. Anytime we want to make a chart, we can say our x-axis, highlight that, press the control key, and highlight our quantity demanded, and then just go up here to insert, scatter plot. I'm going to use a line. You have lots of options, and there it is. And all I've done down here is I've moved my title around, which is I've moved the legend around, so you can go to your layout. Notice this whole area pops up once you make a chart. So if I want to move this, I can say legends. I can put it at the bottom, and there it puts it at the bottom. If I want to add a chart title, I say chart title. I like to put them above. There, quantity demanded, it put that in there. If I wanted to change it, I could go in and I could change it to whatever I want it to be, etc. So that's a linear function, how to model a linear function. And you have this Excel spreadsheet within the Blackboard. You can play around and make it your own. Now, not every function's a linear function. If you remember back to math, there can be nonlinear functions, like as exponential. If you think of, the typical example of exponential growth is compound interest, right? It's as opposed to a linear function that is changing an absolute amount over a given time period, which is the slope. Like I'm adding $5 every month to my bank account, so it's growing as a linear function. A nonlinear is more like a percentage change. If my interest is growing at 5%, Well, if you think about it, 5% on $100 is a lot more than 5% on $10. So you have some exponential growth. So you can have exponential growth, you can have exponential decline. All you need to understand is a nonlinear function is going to be a curve as opposed to a straight line. So again, you can go back to economics because most of the time the demand function is not purely linear because, if you think about it, at some point, there's some items that I wouldn't buy if you gave them to me for free. So they've given us a nonlinear function in this equation. They've said the quantity demanded is equal to price raised to some exponent, which is the price elasticity, which, if you know economics, is just the percentage change as price fluctuates. Anyways, to model this, set it up the same way. Different starting points. Price, they told us the constant, they told us the price elasticity, and then we just went ahead and re-put this formula or this equation into Excel. And we graphed it the same way we graphed it, and just notice that we get a curved line as opposed to a straight line. So a straight line's linear, curved line's nonlinear. Now let's try to pull it all together in sort of a pricing model. All these things we've learned. And this is going to be a prescriptive pricing model. And if you remember, prescriptive means that we're able to look and it's going to tell us what the best pricing is, the best pricing strategy. So just a quick review of some of the functions we've talked about earlier in the chapter. Total revenue is our unit price times the number of units sold. Our total costs are our variable costs, which is units produced times unit cost plus our fixed costs. And our profits are our total revenue minus our costs. They've given us in this problem, in this example, a demand function. It's a linear demand function. Now, because we know the demand function, it's interesting here. I've started out with a starting price in increments. I've changed this around a little bit. Let me change this for you. Let's start at 10 and go in increments of 20. Let's go in increments of 10, see how that looks. Let's stick with that for now. That's the nice thing about these models. You can change them around. They told us that the A was 1,000 and the slope was 5. Now, notice here the unit price. The quantity sold is actually, we use this demand function. Because remember, the demand is going to change, or the quantity produced or sold is going to change. Remember also, for these purposes, we're making a simplistic assumption that the quantity produced and the quantity sold equal each other's, and that rarely in real life is going to be true, but we're making that simplistic assumption for now for this model. So they tell us this is the demand function. So at these different prices, notice our demand is going to change. And because it's a linear function, it's going to change by the same amount. For every $10 we raise the price, the units sold goes down by 50. They told us what the fixed cost was, the unit cost. Here we calculated our variable costs. We calculated our total costs, and we were able to calculate our total revenue. We calculated our profits, which are simply our total revenue less our total cost. Now look what's going on here. It's kind of interesting if we look at this. At the early stages, we're losing money, and then we begin to make money, and then this money seems to peak right around somewhere between 100 and 110, a price of 100 and 110 dollars, and then it actually starts to decline our profits as we raise that price even higher. So a couple ways, if we wanted to say, well, what price level maximizes our earnings? It looks like it's somewhere around 100 to 105. Now, the power of this is we could say, well, let's start at 98. Let's go in increments of $1. Okay, so now our model's updated. And now we can look, right in here, somewhere between $1.02 and $1.03 is where we maximize our profits because we're going up, up, up. So given this demand function and given the assumptions for fixed costs and unit cost, our sales price would be somewhere between $102 and $103 that would maximize our profits. Now, you can do it by trial and error up here. Another way you can do it is you can add in the analysis pack, which I'll show you in if you go to Data, Solver, and you say, set the objective, I want my profits to be maximized by changing my price. And I just put those cells in there. I say solve. I say OK. And it solves it for me at 102. Only thing you have to be careful of is right now in the Excel file I've given you, this is not dynamic. You have to update this with each change of assumptions. But that's how you can take an Excel model and you can do some prescriptive analysis so that the tool will give you at what price do I maximize my profits. Thanks. Any questions? Send me an email.